Let's just wait for 5 more minutes and then we will start. Hi Chintamani, Arun, Sukhsawat, Bhagwat. So great, some more people are logging in. Hi Anto, I'm just waiting for. Is there anybody else logging in? Hi Gaurav. So Hari Vivek, and one more person is missing. Gaurav has come. Bhagwat, Hari. Okay, there's one more person missing. Okay, so I doubt if anybody else is coming. Okay, in case they're coming, they can anyway join. Okay, now let's just check if the recording. Yeah, recording is started already. And okay, great. So, right. Okay, okay. So, good evening, everybody. And in today's session, we are going to discuss about pig and pigletin. And in this session, we basically will be talking about a new language called Pig Latin, and the tool that runs it is called Pig. Okay, so okay, now okay. So in yesterday's class, we do you have any questions regarding advanced MapReduce, combiners, and partitioner, or is there any doubt left which need to be addressed? Do you have any questions related to yesterday's sessions? Okay, then I'm assuming that you don't. Okay, now let us just get started. So, what is Pig? Pig is basically an engine to execute data flows in parallel on Hadoop. Okay, so when you have to execute a lot of queries, then the existing mechanism MapReduce, writing MapReduce was taking too much time, while using Hive based queries and all those things were inefficient. So people came up with something called pig, which basically converts, which gives you a programming interface. And when you write in their language is called pig Latin. If you When you write that code in that programming language, it gets converted into it gets converted under the hood into MapReduces. Okay, and so since we have covered every most of the things related to MapReduce, you will be quickly able to correlate how will a particular logic get converted from pig to MapReduce. Okay, so the language is called pig Latin. Again, it provides operators like join, order by, and filter. Okay, let me just call it order by, filter, group by, and there are lots of operators which are given to the analyst who is going to write the reports or going to churn the data using pig. Okay, so the way you write the pig Latin greatly influences the speed of your outcome. Okay, now it runs on Hadoop. It makes use of both HDFS and MapReduce. Okay, all the properties of both the things. So it doesn't come with its own platform or the backend. Basically, it's a client which takes the programming language from you and then convert that into backend. Now let's have a look at a simple how does it look like. Before I start, let me just try to intimidate you. Okay, so this is how we load a file. Then these are all comments. These are all comments. Okay, this is how we load this file. Okay, and we define a data type of this file called plain text, and the variable name is line. So a single column input is a single column table kind of thing. Now we tokenize line. Okay, tokenize line, then flatten, and then we generate inputs. So now we got words as a big array, then we group by words, and then we do the counts. Okay, so this looks little too big a code for word count. Okay, but don't worry, you will get hang of each and everything what's going on here. Okay, and then you have in last is called dump, which is print statement. Okay, so this is how generally without these dashes, this is comments. Okay, these are all comments. Without these comments, the code is quite precise. Code is quite small. Okay, now let me just move ahead a bit. So Pig Latin is basically a data flow language. Okay, and it helps you describing how will your data flow from one place to another, how it should be read from various files, how it should be processed, and how it should be stored at multiple places. And all of this will happen in parallel. Pig will decide how we can do it at parallel. Then it automatically generates your complex workflows. Multiple inputs are joined, data is split into multiple streams, and and it is not a full-fledged programming language per se, because it doesn't have um, iterative loops like do while or for loop other than for each. Okay, and it doesn't have the conditional operators like if and other things, though there is a bin condition. But other than that, there is no flow controls. So it's not like a proper procedural language for you. Okay, so these are general big points regarding Pig Latin. Okay, so probably this is a duplicate slide, and yeah. So why people ask very frequently what is the difference between Pig Latin and SQL, and this is a very important question to answer. That why did we need a new language in first place? So a very simple answer is the way SQL has been structured or SQL has been prepared is point of view of RDBMS. What does it mean? RDBMS provide you a very stringent schema. Okay, but the on Hadoop when we are running the on Hadoop when we are running the MapReduce or other things, the data is not very strict schema, and there were multiple differences with respect to the underlying system. SQL used to run on a standardized RDBMS, okay, in which the lookups happen on a single machine. So the construct of SQL were not finely tuned for a system like MapReduce. Though it is possible and people are doing it, but it's not very efficient. It's not very efficient. So basically SQL lets the user to describe what they want, what kind of answer they are looking for. While in case of Pig Latin, user describe how to process the input data. Okay. Second is in case of Pig Latin, it's a long series of data operations. Long series of data operations. In case of SQL, it's just one. It tries to answer just one question. So there's not much of a you can't do much of a planning. Say a data comes from here, it goes there, then it gets joined with those two tables. The way to do in SQL is to create temporary tables, which are not very great way of doing it. Similarly, while answering multiple questions or while doing uh, query, the things like lookups on the data, it always requires you to do self join and subqueries and all kind of things. Those are not very suitable for the kind of job we are looking for. Okay. Okay, now let me just have a look at it. Okay. Okay, now the other reason was Pigletin was bottom up designed for Hadoop kind of systems, wherein we do all of the execution and processing on a file system which is located at multiple places, a distributed file system and distributed processor system like Hadoop and HDFS. Okay, so that's pretty much about it. Okay. And in case of Pig Latin, there are multiple kind of optimizations. Pig and Pig Latin, Chintamani, basically Pig is a full underlying engine. Okay, while Pig Latin is the main language. It's like saying C and C compiler. Okay, uh, or Unix and shell. Okay, so it helps you execute everything. You write your code in Latin, and then it gets converted into MapReduce underline. So you can think of it as an interpreter, which converts your Latin into MapReduces. Okay, and basically SQL is for the data which is well formatted and has a very strict schema. It is for loose schemas. Okay. And it doesn't SQL doesn't do any optimization for parallel processing. Okay, that is why SQL was not fitting very well for big data processing, and MapReduce required lot of coding skills. Okay, MapReduce required a lot of Java skills, Python skills, and the whole turnaround time was big. That is why people came up, one person or some OLAF, I think, came up with this language. Now let me, okay, and ho- so we talked about how is it different from SQL. Okay, SQL was finely tuned and designed bottom up for RDBMS. Pigletin was designed for big data solutions, or Hadoop and HDFS. Similarly, there are differences between Pigletin and MapReduce. The most important reason is that to do, as we showed you in the last exercise, to do a simple join, you remember the question related to the this polling voting system. There was a last question in which we had to join the two tables. It required an enormous amount of work. We had to write two sets of map reduces to join two tables, and joining two tables is very frequent operation when it comes to data churning. Okay. So the more code you write, the more buggy it will get, and then it will take a lot of time. The whole turnaround time will be higher. Okay. So the main reasons are those. First is Pigletin provides you things like join, filter, group by, order by, and union, similar to SQL, while MapReduce does not do it. But you can emulate all of it using using MapReduce paradigm. Okay, and Pigletin provides you optimization such as rebalancing the reducer, which MapReduce also provides you, and it's little difficult because you will have to write the partitioner and rebalancer. Second, Pigletin, because when you are writing any code in Pigletin, you keep on describing your data. And when you try to reassign, assign, or try to group by something which is not supported, or there's something, some other error, Pigletin immediately tells you that, hey, you are doing wrong things. It doesn't have that column, the column on which you are trying to group by. But in case of MapReduce, the complete error checking is left to you because it has given you the complete control. Okay, it doesn't understand exactly where the error will occur in your code. Okay. Similar argument is with respect to the strongly typed languages and completely loosely typed languages. Okay. So basically, Pigletin tries to understand what you're trying to do by the way of queries, and hence it is able to predict that you are trying to assign, or you are trying to group by on a wrong column, or similar to SQL checks. Okay. Then basically it's a smaller code, so it's very easy to maintain and easy to write. And in case of MapReduce, there is a compile, compilation step is also there. So first you write your code, compile it, then transfer it on the server, and then run it there. And here it's just simply, going to the command prompt and start testing it or running it. Okay. So Pigletin has got limitations. If you are trying to do something really, really different, such as our anagram question, it's very difficult to do that using Pigletin. Okay. Anagram as in the DNA question, DNA question, where we were trying to do reverse and check. So that kind of question is difficult to do in case of Pigletin, while it's very easy in MapReduce. It gives you a complete control. So rebalancing the reducer means number of reducers. How many reducers do you want to run? That is rebalancing the reducer means. Okay. Now let me move on to the next slide. Big use cases are basically, first is an ETL. ETL stands for extract, transform, and load the data. Okay, so pig mainly is used first you doing the ETL. Okay. Chintamani's question is, I'm not getting the primary purpose of pigletin. In very simple words, most of the job, if you have a good programming skill, almost every job can be done using MapReduce. But it requires a lot of effort to write a lot bug-free code, and there will be too much of code. For doing trivial tasks such as joins, you might end up writing a lot of code. Now the other end, this is first end. Second end is that you write code using SQL, using Hive, but that is not greatly efficient. But that is not greatly efficient, and that is why the authors decided to write a new programming platform where you can immediately write a query and it gives you the output. Okay, but under the hood it is also basically the amount of effort you would take to write a simple join. Pig has absorbed that. Okay, so basically you can think of pig as somebody who does sorting for the common programming tasks such as sorting or order by, filters, and joins and unions. This is an abstraction over MapReduce. Okay. So Bhagwat's question is, when you mean MapReduce, the general concept, or Hadoop's MapReduce? It runs on Hadoop right now. Okay, it runs on Hadoop. So we are talking here MapReduce in context of strictly Hadoop. Okay. And these are so first one is ETL. Pig helps you doing the extract, text, and load. This is a complete branch of the computing where lot of data is pushed into the from unstructured to structured format, converted from structured to unstructured format. Okay, and then you can do a research on data. When you have scripting at your hand, you can quickly churn the data and see the insights. And third is it helps you doing the iterative processing, meaning that as your data gets increased day by day, it is easier to basically do the processing. In other words, it helps you processing the data easily. Okay. Now these are four basic philosophy which has been taken into consideration of pig design. These are the design pillars of pig. First one is the pig eats anything. So Chintamani, is it like ab initio? It is only for ETL? No, actually if you look at it, it is ETL plus SQL combined together. Okay. So it is SQL kind of a language. It is similar to SQL kind of language, having major differences also. But you, for an end user, you can always think of it as a new kind of SQL, and which helps you even in at ETL. Okay. Yeah. Does it have? Yeah, it is the script. Pigletin is the script. Okay. I'll. I think I should have. This is the only screen which will. So this is how it looks like. This is the pigletin. You say load this particular text file into this variable. Okay. And this text file is having one column. Let's give it a name called line. Okay. Then you split, you tokenize the line, and then flatten it, meaning convert these words into one per column, one per row, one word per row, and now you get a full words. You get all the words in the line, and then what you do is uh, uh, you group by those words by word, and then you count all of those, and that's how you do the. So this is how it looks like, Chintamani. Hope that gives you answer. Now, the pig's general philosophy is pig eats anything. Unlike, okay, so pig eats anything means it handles any kind of data, whether it's relational, nested, or unstructured, it has to handle that. Okay, pig lives anywhere. It is basically, it's the whole paradigm though has been written for Hadoop should also work for other distributed platforms. Okay, but I'm not aware if it has been written for any other platform, but it has been very well used with Hadoop. Then pig are domestic animals, meaning pig can be controlled easily and are not unruly. The paradigm is that the any construct of the programming language should be well controlled. Unlike the browser, where you have no control over the browser most of the time, you try to keep on guessing, it has to be very, very predictable and controllable. Okay. Controllable to an extent that the whole parallelism should also be controllable. How will it execute in parallel? Okay. So such and it also provides you it lets you control things, it lets you write custom functions in Java and Python, and then it also gives you a custom mechanisms to customize the load and uh, store functions. And pigs fly. So the main reason why pig was designed in first place was to replace SQL for parallel processing, and the reason was that to give a better performance. Okay, so pigs fly means it has to be very performant. So these are the four design pillars of pig's philosophy. Now how do you install it? First you download this particular release. I'm using this particular release, which is latest. Okay, from that page, pigs release page, and then you do extract that file, then move that folder to this location, set your Java home. Okay, whatever is your Java home, I have given, in my case, this is the Java home, and then run like this, pig minus x local. Right now, it does not, so it comes with two modes. One is using Hadoop, and other is without using Hadoop. Okay, so the local pig minus x local is meant for running it locally. Okay, running it locally meaning it doesn't have to, it will not convert it into MapReduce, it will just give you the output. It uses the emulated version of MapReduce for local. Is that emulation given by the Hadoop guys itself in a separate jar file, which they bring together. So pig minus x local does not need to connect to MapReduce. All it requires is Java home directory. So you extracted and started running it. Yeah. So pig itself is written in Java. Yes, it is written in Java, I think. Okay. As far as I know that it is written in Java, I think. Okay. Then once your pig starts running in the local mode, it is time to start in the Hadoop mode. For that, you will have to tell pig by way of describing a variable called pig underscore class path, and point that class path to the folder where the configuration file of Hadoop is lying. Otherwise, it will give you an error saying I tried these two folders but could not find the config files. And once you do that, so you created two variable, Java home and pig underscore class path. You can Also mention these in your dot profile, and so that every time you run it, it is there. These are automatically set. Every time you log in, these variables are already set. And then you have a pig bin folder. Add the pig bin folder to path, so that you don't have to give the absolute path every time to run pig. And then run the pig command, okay, and enjoy the grunts. Okay, grunts, why I say is because when you type pig, the command prompt is called grunt. And for us, you don't have to go through all of this. You don't have to go through all of this. I have already set up. Okay, so SSH to student at hadoop3.nobigdata.com, and password is same as mentioned earlier. Okay, and then you type pig. Okay, there is no web interface right now on Hadoop 3. Okay, because Hue is taking too much of memory on the machine. That is why, to save some memory, I've just installed Hadoop Vanilla, and also installed the I mean this pig on that. Okay, so so to try out pig, you need to do ssh student at hadoop3.nobigdata.com. Password is same as we have mentioned earlier, and to become passwordless, you can copy your public key. So there is a mechanism. If you search for passwordless ssh, you will understand all of it, and then you don't have to keep on sshing, entering the password every time. Okay, so SSH to this server, you already know the password, and you type in pig, and then start working. And I have created one folder called users student, in which you will keep all of your data under your folder. Okay, all of your data under your folder, and uh, then start working. For time being, for all the exercises, I've created all the data here on in the HDFS. Okay, let me show you. Okay, okay, let me see if you can see my command prompt. So this is my local laptop's command prompt, and then I say ssh student at hadoop3.nobigdata.com. Okay, it is taking a bit of time. Now here it is. There, if you see here, locally also there is a data folder. Okay, locally also there is a data folder, and these are my logs also. I'll just delete the logs. Now these are the data folders. One is baseball, other is New York Stock Exchange daily ticker, New York Stock Exchange dividends, and these are the file I'm going to use in for this demonstration today, right? And then I have these things are not required. Okay, okay, okay. Now I'll show you some things. So also I'll show you where on Hadoop you say Hadoop fs minus ls users and student. This is where all of your data is going to get stored. You can see, right? Uh, so these are the folders. NSE dividends, and then there is a data folder. It contains everything. These are the files. New York Exchange, daily, dividends, readme, baseball, web crawl. All of these are also uploaded onto Hadoop. So this is my local. So first of all, as I told you, to run Hadoop locally, password is same as the previous one. Okay, password is same as the previous one, and actually I cannot open the password right away, but I'll tell you. Okay, so password is same as the other servers. Now pigx local does it locally. Okay, all the files whenever we mention local will be local. Okay, let's say I'm trying to load. Wait a second. So let me go to the data folder and then run pig minus x local. Okay, and I say pets equals load pets dot csv pets.csv, and then that's it, and say semicolon to terminate it. Okay, and so the data has been loaded from pets.csv into pets. So I say dump pets. So this is the data contained in pets. Now if you look at it, what did pets had? Pets.csv. This is the file which had this data. Pets.csv is containing comma separated values. Okay, and it got loaded into the memory quickly. Okay, and similarly, hello, yeah, hi, actually, Bhagwat and other people, are you able to understand? Are you able to hear? Okay, okay. So let me just repeat. So basically, I have logged into the server and I have opened a file called, let's say, I'll just open a easier one. Let's say people. People are city and name, city and name. Okay. Now this file contains two columns, tabs separated, city and names. Okay. Now I will load it into pig. So let me start pig in the local mode first. In the local mode, it does not connect to your Hadoop installation. I'm saying people equals load the file name called people. So in the code, okay, to avoid confusion. Chintamani, a better thing would be to disconnect and connect again. Okay, I will anyway repeat all of this which I'm describing just now. Okay, anyway, he is not able to hear, so I have to type. So, so I say P equals load people, and then I say dump P. Now you see, it has loaded it. Okay, it has loaded it into memory, parsed it and loaded it in memory. Okay, and we can actually you do all sorts of operation like grouped is equals to group people by okay, I have not here. While you load, you define uh, the columns which you are expecting so that you can refer these. Okay, now if you say dump p, I'm sorry, dump p, it will give you these. And if you say group is equals to group p by, say, city, and that's it. Okay. Now G is your group, and if you check what is inside group, you will see this. So it has grouped those things by city. Okay, it has grouped those things by city. Okay, so Gaurav's question is interesting. I too had the same query. Okay, so anything I am writing just now, if we can look at the MapReduce code in Java, and then we can optimize if we want. Okay, all right. So you can write help and see the command list, Shashank. I will describe each and every command in detail. This is just to show you that there is this command prompt and which is working. So right now I have not seen a way to look at the Java code, but I'll definitely look into it, Gaurav. And right. So what people do generally is, if there is a logic, complex logic such as you are trying to encode or decode something, you write in Java and then use that particular function in your pig script. I'll show you that part also. Okay. So I was trying to show you, this is how you generally uh, work on the command prompt. I have control C and then exited from it and then getting back to this. Okay. Okay. So Bhagwat is saying he's not clear. Don't worry about it. Okay. Basically, I had just given you a demo of local. You can also do the same thing. Okay. You can also do the same thing. But so say you want to. Okay. I think I will give you a better demo. Yeah. So basically, it's a local mode. It's sort of an emulator. Okay. And if you don't want to run it in emulator, you can run it in the direct one. Okay. Pig, if you say simply pig, you will be connected to the MapReduce, Hadoop MapReduce, and everything you do will talk to Hadoop. Okay. Right, right. So you don't have to, if it is no, hold on. So there were two installations I was talking about. First one is your local one. If you are very keen on trying to install, because somebody was asking me yesterday also, but I don't foresee that you need it right now. Okay. This is the mechanism where you need to point to Hadoop installation. Okay. And here you don't need to install anything. You can simply go to SSH and do the same thing. Can we write the same script in PigGUI? Yes, yes. PigGUI is nothing but basically a large text box which sends the data back to the command prompt and gives you the output there. Okay. But PigGUI is not right now available because the GUI is given by a tool called Hue, and it seems to take too much of memory to run on the single node. Right. Bhagwat, because this screen is getting recorded and is going to get available to people later on, I will not be able to share it with you, okay, right now. And wait, I'll basically stop the recording maybe. In the installation folder, have you looked into it? sorry, not installation folder, installation instructions on the day 0. On the session 1, you will see installation instructions. In that, there will be the password of the student. Okay. And also, okay, just a second. If you guys don't mind, I will look at it. Okay. Are you able to find it? Right. Because he wants to try while we talk, right? That's also a good way, but it will be a little bit of distraction. Now I have uploaded most of the data in this HDFS location and also in the home folder of student. Now there is a local mode which works without Hadoop installation, very useful for testing locally, improves your development pace. Okay, which I just showed you. And then there is a command line arguments for the pig command. Basically, pig is pretty useful thing. I'll show you how. So when you have written the pig script, you can call that script by just saying pig and script and it will get executed. Or you can keep on writing the commands on the command prompt and get it executed immediately. Also, you can execute the commands like fs using the pig. Okay. Or you can execute the same commands using the pig command line. If you say pig minus e, anything you can do on the command prompt of pig will get done from the arguments also. And you can see all these details by doing pig minus v and pig minus h. Okay, so this is the grunt where the whole thing starts. So now I'm here and I say pig. Now I'm connected to the Hadoop system, Hadoop via pig, and anything I do here from here, like fs minus l users students, this is going to query the HDFS and give you the results. Fs minus ls. Do you see? This gives me the complete results of their Hadoop there. Okay. Similarly, it also helps us in doing other kind of things such as copying a file. Say I want to say fs copy from local and I say people, the file which we just generally just loaded, and I'm trying to copy it into HDFS. So like this, it got copied there. Okay, so fs command is completely supported on grunt, so you don't have to get out of the command prompt. And you can also kill a running job in Hadoop and execute exec or run a pig script. There's a difference. So you write all your code either on the prompt or in a separate file. You can call that from inside of pig and execute that script. Okay. If you do run will basically any changes you make in the pig script will reflect in the current prompt also. Okay, similar to your Unix shell. Okay, now let's have a look at a very simple, most simple script I could think of is this way. Let's say we have got a New York Stock Exchange data. It has got the exchange name, which is New York Stock Exchange, and then ticker on which stock, basically stock quote we call it, and then date, and then the actual value. Okay, New York Stock Exchange, these are the dividends value of each quote. What we want to do is we want to do an average. Okay, we want to do an average here like this. Okay, if we had to do it in Hadoop, what we will do is we will write our first map which will make the stock quote as the key, and inside the reduce we will do the average of all the values, right? Here here it is comparatively simpler. All we do is first load that file's data, this file's data. Okay, we load. So let's go step by step. First step is load that file's data. You see the colored word is the keyword. Load this file into this variable, and this the format is that these are the four columns it contains: name, ticker, date, and value. Then we say dump just to test whether it has come or not. So I'm just copying this and pasting out my command prompt just to give a demo. It is loaded. Now I say dump divs. It is going to scroll very fast because there is too much of data. So this is how this, so it loaded that data into the variable, and I say dump is equal to saying print. Okay, and it dumped all of the data to me. Now I can also do explain. Okay, explain divs. Explain shows you the complete query plan, while describe, if I say describe and say divs, it shows me the data type of this particular table or schema of this table. It tells me it has got these columns: name of type string, this is string, byte array is string, and then ticker, which is a byte array, and so on. Okay, not byte array is just another array of characters. Okay. See, then once we have test checked that everything is loaded, then we do group by. Then we iterate over the data and compute average. Okay. Iterate over the groups and compute average. This is equivalent to reducer. This is equivalent to map and shuffling. Both the things are happening there. And then we store the output of, so we loaded the data into divs. We uh, from the divs we created groups, and groups are stored in grepd, and then we iterated over groups and stored the result and average values into aveg, and then we stored this into this particular file. Okay, let me just do it. Now I'm doing a group. It is grouped. We can also check it how it looks like, but that will be just another thing. And then average we have saved into, and now we are dumping all of it into this particular file. If it gives us an error, it says output directory already exists, we can say 1, and it will, now it is creating MapReducer. It is doing MapReducer jobs right now. And it similarly, if you remember, when we were executing our MapReduce, it was giving us the task tracker and everything. Okay. So okay, it is running the job. It is saying 50% completed, and again it is running it. Good. Now it has run it and stored the data into this particular folder. Okay, and similar to our MapReduce result, from here itself we can say fs minus ls, and we can say this. We are querying our HDFS, and there is a file called part. You see part and s. Here you can say part and star, and then we can say fs minus cat, this. So this is the average value of all of these uh, symbols. These are called symbols. Okay, these are symbols. Cool. So I just demonstrated a simple pig script, how to run it. If you did not understand any of it, do not panic, because the idea was to just give a very quick overview. So Gaurav's question is, uh, this is like a pig client from we are submitting pigletin to pig server, which generates MR code and execute that in Hadoop. Right, right. So there is no such thing called pig server. It's the client only. It doesn't install or run on any port. Okay. All we do is we execute this client. This client creates MapReduces and talks to our Hadoop MapReduce, and that's it. Okay. Right. What is LGOS jar? Logs jar. Okay. Okay. Right. Right. Let me just move, because today's class is little maybe beyond the scope. I mean, cannot be completed in 3 hours time. So maybe I'll have to spill it over to the next session, but do not worry at all. Okay. Right, right, right. You can do that, right? So Gaurav, so what Bhagwat is saying, that there is some jar being generated and being used. You can have a look at that. Okay. It's basically in the /tmp, there is a folder called map-reduce where it dumps your jar for temporarily. Okay, that you can look at it. Okay, I will also look into it. It will be interesting. Okay, so here I just gave a demonstration of a simple average computation of stock symbols, right? Now the whole of rest of the class is going to go into details of one by one. The way we learn any programming language, it starts with the format, how do we run a script, a hello world, and then we start with the basics like what is the syntax, how do we write commands, then data types, then we talk about each construct, each what does a loop does, what does a group by does. We'll talk about each portions in very detail from now on. Okay, here we just gave you a cursory look at the general way of running a pig script. You so general In general, you load the data from a file, and then you group that, and then you do a for each, and then you store it back. So these are the basic mechanics of running a pig program. Now pig has got something called data types. As you see in here, we just said these are the 4 columns we are expecting in this file: name, ticker, date, and value. Okay, these are the 4 columns we are expecting from this particular file. Now we have not said anything about data type, right? So Hadoop is trying to guess it, and the way it guessed it is it marked everybody each of these values at byte array. Okay. So those are the kind of data types, and so basic data types are similar to Java: int, long, float, double, and char array and byte array. Char array is equivalent to string, because anyway it is going to get converted into Java, so it has to keep that thing in parallel. Okay. It's not a strongly typed language, but it is not also completely loosely typed language. Not really, not really. Byte array is properly an array of bytes. Okay, we have a byte array type in Java. Similar to string, which is an array of characters, byte array is anything. It could be anything. Array of bytes, binary data basically. While you are manipulating something in binary, void star is generally considered, I don't know. I thought you're talking about a return type of a pointer. Maybe I don't know about, I forgot my C. Now, in case of the other, there are two data types. One is simple, basically primitive kind of thing. We call them scalar, and then complex. Complex is very important to understand. So first one is a map. Map is nothing but a collection of key value pairs. Okay, like name is Bob and age is 55. In this, the name always in a map is a key and value pair or name and value pairs. Okay, name is always a character array, while the value can be another complex type or it can be a scalar, meaning the value can be further another map, tuple, or a bag, or it could be simple int long string and byte array. So those are the so this is how a map looks like. Map is basically a hash table. Okay, hash table of key and values. Then we have something called interesting aspect called tuple. Tuple comes from the tuple algebra. Tuple algebra, in tuple algebra we used to call a row as tuple. Okay, if you guys have been to tuple algebra, has studied, so in RDBMS a tuple is basically a row. Okay, so other complex type is tuple. Okay, it has got a fixed length and ordered collection. Okay, meaning and also it has got field and value format. Okay, so tuple is nothing but a kind of a row in which we store a data, and it is ordered unlike your map. And then you have a bag. Bag is nothing but a sort of, you can think of an array. Bag is nothing but array of tuples. Okay, array of tuples. And example here is your, this is a map, this is a row, which is, it contains the Bob and 55 and 20.3, and you can also, every of these things is going to have a name. If it doesn't have a name, you can refer it by the position $1, $2. Okay, and then you have a bag. Bag is nothing but a set of tuples. Bag, you can also say that this is a rows of a table, or it can be considered a view of a table, or can be, you can also say it a table. So basically it's an unordered collection of tuples. Okay, and whenever you do select star from blah and blah, you always get a bag. Okay, bag contains these uh, uh, this collection of rows or collection of tuples, we can say it. So bag is more or less analogous to a set or a table or a view. Okay, so the important property about a bag is that it does not need to fit into the memory. It spills over to the disk. If it goes beyond the RAM, it spills over to the disk. Okay, and as a general thumb rule, whenever we are computing how much memory our complex data type is going to take, it is always 4 times the actual one. Right. So Chintamani's question is, will pig put data somewhere like a database? So you can use a pig to store data back into your database. Here we are trying to store it to the file. Okay, can see in this. Right now in the flat file, but if you say using this particular method, say hbase catalog, then it will use the hbase library to save it to the hbase. Right now it is storing in the flat file. Okay, so this, it does that way. Okay, so we were talking about the data types of the pig. It has got basic simple data type int, long, float, double. Then we have got complex data types. Right, HBase is the database on Hadoop itself, which we will take care in the next to next class. Okay. Now the data type has got complex. Another kind of data type is complex, in which you have map. Map is nothing but a hash table. Tuple is nothing but a equivalent to your. You can think of it as a row of your table. Okay, row of your database table. And bag is nothing but a, you can say it a table. Okay, it's a set of tuples. So we have got map, tuples, and bag. Okay. Now, Pig is not very particular about schemas. Okay, and you can either tell Pig that, hey, this is my data type, this is the column data type I'm expecting, or let Pig do the guesswork. Okay, it takes a safe, safe assumptions, such as most of the values will be considered as a string or byte array when you don't specify, when you don't specify a data type. So while loading itself, you tell load from this particular file, New York Stock Exchange underscore dividend, as this data type, which means first column or first field is going to be exchange, and my data type is char array, symbol is char array, date is again char array, and dividend is float. Okay. Also note that there is no special type for date right now. Okay. Now when it loads it, it will basically load it using tab separated mechanism. It will consider the input by default as tab separated unless you have mentioned as comma separated handler. I'll come back to that in the next slide, how to load a comma separated value, but by default it will consider it this file to contain the tab separated values. Okay, if you do not specify all of this, any of this, then also it is okay with our pig. Okay, it will take the safe assumptions and build the data structure. And and the only drawback, if you say, if you don't specify the data types, it will consider all the data types as byte array, or it will do some certain assumptions also. And in case you specify it, in case you don't even specify the column names, then also it's fine, just that you will have to refer to each value using positional arguments like $1, $2, $3 rather than their names. And when you are calling, okay, when you are calling the schema, when we are describing that, hey, my data, while you are loading the data, it might be in this format, you can give all of these kind of details also, such as we can tell that this particular column contains map values, okay, or this particular column contains tuples, and we can specify the data type of tuple like this. Okay, every tuple has got some kind of basically data type also. Right, right. So I will show you that part also. There is a way to define it. Okay. So if exactly in the same fashion, curly brackets and then values, then round brackets and then values, then it will be considered as tuple. Okay. Then it will be considered as tuple. If you there is a here, if you look at a folder called data, and then you have, just give me a second. So there is a file called baseball. Okay, if you look at the file called baseball, it will show you a lot of this same question. So, and I mean, I'm sorry, I did not mention that. Basically, Anto's question is that uh, this data is in some format, or is it? So you can look at this. Okay, you have got a string, then tab, then another string, then tab, and then you have got basically a bag of things. Okay, bag of tuples, and inside it there is a single tuple called third batsman. Okay, and then you have got basically a map here under square brackets. Okay, this is the map. Okay, till long map, and then and so on. Okay, so the data is described exactly in the same format, right? So a tuple is generally described using round brackets, and a bag is described using curly brackets in the flat file, from where you will load or while writing, both the cases. And map is described in terms of square brackets, and key value are separated by a hash, just like here. You see this? Exactly this way you will also store it. Okay, like this, like this. This is how you're going to store it also. Hope I was able to answer your question, Anto. Okay. N- Now we can all while loading we can specify all of this in detail, saying, hey, B is the variable which is of bag type, and inside that the tuple it contains is X and Y, out of which both are integers. Now it will load it in this fashion and you can operate upon it. Okay. Also, when you are translating or transforming this data, there are times when pig hasn't done a great work. You can force pig to cast one data type to another. Okay, and the casting is exactly like your C or any other programming language, where anything can be counted, anything can be casted from integer. Anything can be. So somebody has got disconnected, probably Chintamani or somebody has got disconnected. He has sent me as an SMS. Okay, so the casting is possible. Like in Java, we can cast anything from number to float into a string. So similarly, there are certain ground rules which similar ground rules Pig also follows. Now, basic construction of a Pig script is each processing step results in new data set. Yeah. So yeah, data file needs to be formatted in certain manner. In case it is not formatted, then also using pig script, you can transform it, and then it will be formatted properly. You can you assist by using your script. You can format it. Okay. So the basic format of a pig script is each processing step, whether it's load or whether it's group by, order by, or join, they all result in a new data set. Okay, new data set. And even if you are saying assigning to the same one on which you are operating upon, it is going to create a new data set. Okay, but don't do that ever. You are joining A with B and assigning back to A. Okay, is not a great idea, but still it doesn't harm pig anyway, and in that case also it will create a new data set. Okay. Second is that it is more or less case insensitive except for the cases of function names. So when we are calling like average or other things, In those cases, it requires that avg to be capitalized, right? And if you say small, then it gives an error. Okay, I could show you. Okay, here if you say in small, it will give an error. So it says built-in not found, could not resolve it. Okay, so right now as you are doing, going from the step 1 to step below, it's not doing any execution for you. The moment you say store, or the moment you say print or dump, that moment of time it is going to do the parsing and then do the execution. Okay, and in the all these variables, while it does the processing, all of these variables, some of them are going to be in memory. If they are spilling over, as I described in the previous slide, a map, basically a bag of tuples is going to spill over to the disk. Okay, does it keep all in the memory? A equals join AB means we have three tables or two. So you have in this particular context, in this particular script context, you have three. Okay, you can use. Okay, so I'm sorry. Basically, A equals join AB means we have three tables or two. At the end of this, you will have only two tables. The A will be overwritten. Okay, but the memory allocation is for three. It will take some time to delocate it. And then you have multi-line commands like your C programming language, and dash dash is like your SQL. This is a single line command, this is multi-line. Now the basic one, the first one I'm starting. So I'm going to go this way. I'm going to go from one operator to another and so on till the end in this class. Okay. And I'll be slow because I will see. I mean, there are a lot of things to cover, but nothing to hurry. We will take care of in the next session. Okay. Why it's not getting selected? Okay, I can get selected. Great. Now let's have a look at it. What we're talking about. So first and foremost is how to read the data from the files. Okay. And actually, I even don't know how to read the data from the command prompt. I haven't seen a function yet, but there would be some function to load the data from the command prompt. Okay. Right. So here you say diffs equals load file name. This file name, if you are running in the pig-x local, then it will expect this file to be available in the same folder from which you started the command prompt. Otherwise, it will expect it to be somewhere on the HDFS. Okay, and by default, HDFS gives you the default folder as the similar to your home location. Okay, now this is how you basically load this file into this variable without, and let the pig do the guesswork for you. The default guesswork which pig does it expects the columns to be tab separated. Okay, and considers most of the values into string. Okay, you did not tell anything other than saying, hey, load from this file. That's it. If it doesn't find any tab in the line, the whole line is going to be a single value. Okay, the tuple is going to contain only one value if in case there is no tab. Okay, now You can also give a absolute URL or relative URL. Okay. And here you assisted pig a bit saying, hey, my input file is should be read using a mechanism or using a formatter called pig storage. Pig storage is one formatter which reads input file, and you can specify any kind of separator. Here we have specified comma. Now it will expect this particular file to be in comma separated format. Okay, so this is the way you read a CSV file. Then if you don't know or you don't want to type the exact value, you can do the globbing the way it happens in case of default file systems using this. Okay, you can say A and then star B and all sorts of formats. So globbing is completion of wildcard characters. So you can specify wildcard characters. Then you can also read from HBase. HBase is a database provided by Hadoop which runs on top of HDFS. Now this is what it is. So it will load NYSE underscore dividends table from HBase. Okay, or column family, whatever you want to call it. Now, in the next kind of syntax, we are saying that, hey, we know our data type, we want to give each column a name. Okay, we want to give each column a name. And we can also define the data types upfront by saying this is a char array and this is our char array and this is our float. So it's up to completely you. How do you do it? Okay. Bye, Gaurav. And Gaurav has to go somewhere. And yeah, we'll catch you later. Bye bye. And this way we can define the data type howsoever you want it. Okay. So basically these are the various syntax of loading a file. And this format of as I mean, where we are saying that load this into this, and these are the data type we are expecting. This is also true in case of when a new column generation happens, such as while doing the projections, while doing a group by, you can also specify the same thing there also, similar format. Okay, so this is the basic construct of a load. Now, after you have loaded the data, you can say explain dataset, describe dataset. Okay, so explain dataset shows you a detailed analysis of the query, and describe dataset gives you the schema of that particular dataset. Okay, and also if you are planning to write more of pig script, then there is a syntax highlighter which helps you making less mistakes or highlighting your errors then and there while typing. Okay, so there is a Eclipse highlighter, and then you have Emacs, Vim, and TextMate syntax files which you can load. Okay. So this is for the diagnostics, quick diagnostics. This gives you a detailed query plan. What is going to happen? This is going to give you a detailed data set is schema. Okay. Now, then after loading, the other one which is important is storage. So storage stores the data again in the tab separated format, and the format which it has described for maps, tuples, and bags. And then we have something called dump. Dump basically gives you the functionality of printf. this basically gives you a functionality of printf, and this is very very useful to debug. Okay, the syntax is this, right? Any questions still here? I'm actually moving a little bit faster. It will give an error. I mean, it will give an error when you dump the file. Okay, and I think it gives the error before that. You can actually try. You can actually try. So here I'm trying to load a file, and I'm okay. Here it doesn't give you an error right away, but if you say dump divs, then it gives you an error. Okay, error, unable to set up the load function, and on top of it, it must have told in the upfront itself here. Okay, basically it's not very okay. Here it doesn't give an error, but when you say explain divs, okay, it says fake file and then no map reduce plan. It's only this, and then you say describe, and it says this. If you say dump and divs, it gives an error. Okay, okay, it gives an error here. So if you specify a file which does not exist, only in case of dump it will give an error because it starts executing only after you have done dump. I'm connected to the normal. I mean, I'm not connected to the local. I'm connected to HDFS. Okay. So Anto's question was, how do you use Eclipse Highlighter? Do we have option to write Pig script in Eclipse? Yeah, it gives you a choice of basically writing a script in Eclipse itself. And also you can configure your Eclipse so that you can quickly run your script through a pig minus x local way. There is a very neat way of doing it. You can configure a tool in the, I mean, you can say run, and in the run itself, you can configure a tool to execute, and that's it. Okay. And before that, you can configure Eclipse to import a highlighting file as mentioned in the previous slide, and then it will start highlighting your pig scripts. So whenever you say file new and pig script or with the extension called .pig, it will start highlighting that file correctly. Okay. So dump does the printing work for you, uh, and also it could be used in cases where we want to store our variable values into a file. So you could say dump xyz in your script and run this script using pig, and then you give that script on the command prompt. So it will run it, and whatever output is there, you can redirect that output to a file, and that way you can save the output to a file also. Okay. Right. Okay. Welcome back, Shashank. Okay. Do we need dump for executing pig? So basically, pig decides at various points when does it need to start execution. Okay. And that trigger is first trigger is the dump when it starts the execution. Okay. And other is store. Okay. So before that, it doesn't do any execution. Okay. When you say load this, load that, it doesn't really load it. It basically defines it and keeps a pointer to it. And even in the group by and everywhere, it's like declaring that I've grouped by. And later point of time, when you're saying store or dump, then it goes back and forms all the logic to does the real execution. Okay. Similarly, we can store using pig storage and in the comma separated fashion. You can also store to other third party things such as H-based catalog and everything. And this is pretty much with respect to store and dump. Now let's see what it says about relational operators such as, so each of these things like load and for each group by are considered as relational operations. Okay, we will call them simply operations. So first and foremost, which we talked in the first slide, is for each. After we have done loading of this data into divs is a data set, okay, or data set, as well as it is also called a relation. Okay. In the speak of relational database or tuple algebra, we call it a relation. But a data set sounds better to me, so we'll just stick to data set. And they also use it interchangeably, the data set and relation as the keyword. So we loaded our file into this data set in the format of a bag containing this tuple. Okay, a bag containing this tuple, meaning a table containing rows of these columns. Now we did a group by just ignore for time being, and then we did a average, right? So what does for each do? You can think of for each as a mapper job. Okay, you remember mapper, where we went from row by row. Okay, so here we are saying whatever was the output of grouped, okay, go row by row and do generate and various columns, and we can also do an operation on those values. Okay, we can also do the operation on those values. Here we are doing an average of an array of values. This array was generated by group by. Okay, so in general, for each is like projections in true sense, where we go row by row and do the transformations on those. Basically, each tuple, each we go by tuple in this bag of values, which has been generated by group or anywhere else, and then or you can even run for each on in divs if you want to say multiply, or say or say you want to convert the date into another format. Okay, or you want to do a multiplication by 10 on values. In that case, what you do is you run a for each clause on top of divs. Okay, and then you can do any operation on it. Here we are only doing a single operation called average. Okay, here hi Shashank, I mean it will be difficult right now. You have not missed too much, but the starting you have missed a bit. Okay, so try to understand what is going on. In case there is a confusion anywhere, just ask me upfront. I'll clear that. Okay. Now, so this is the for each. This is the for each where you go row by row or tuple by tuple. Row and tuple I'll go use interchangeably so that you get used to using the two words together, as well as I'll use the table or set interchangeably with the bag. Okay, so in this bag of tuples, we go one by one by each tuple and operate upon it. That is the role of for each. The syntax of for each is for each and then your bag name or your set name and then generate and then you write what are you expecting. And remember, although it looks like that we are doing a group by, but no, the grouping here done by this clause. It generated it generated two things in each row or in each tuple. You generated two things. First is divs. First is ticker, which is the key, and the value is an array of uh, all the other values for the same ticker. Okay. And when we say average, it is those values which we are trying to average upon. Or you can think of it has generated, what it generates is ticker and ticker, comma, an array of all the values. Value 1, value 2, and so on. Okay. It generated that value under divs.val. Okay. You can think of it in that terms. And then it is doing the computation. Now Bhagwat's question is, every variable will take same amount of memory that can easily become a lot. So this, see here, it's not doing anything per se, right? It is not really loading it into the memory. All it is doing is it is assigning a name to this operation. It is assigning a name to this operation. It is assigning a name to this operation. And the moment you say dump, AVEG, AVGED, what it is going to do is then it is going to prepare all your map reduces, which will go to the server and then will get executed. It does not mean that we loaded everything into the memory. No. Okay. This is just a symbol. It is as if you are actually writing the Java code which is not yet compiled. And writing dump or saying store means that you are trying to run it now. Okay. No, okay. So that's what it is. So this is the more or less for each syntax. Now the other these are the other cases. You could use all the arithmetic operations inside after the generate. So the syntax is for each, then prices. Prices is you loaded this New York Stock Exchange daily ticker into prices, and prices basically is a set representing this operation. So whenever we do group by adds a column to the whole table called group with the name called group. On whatever value you are grouping it, it gives it a name called group from which you can reference it back. And that's what we're trying to do. So, and rest of things go under the values. Now in the generate, we can do operations like subtraction. Here we are trying to subtract one column value to the another, close minus open. Okay. It is like saying select from table. This is equivalent to saying select. Okay. Select close minus open from prices. This is what it is equivalent to. Okay. So right. That's a very interesting question. Thank you, Hari. So in case you are creating a newer column, it will not give it a name. You can write as my column. Okay, as my column. It will only generate this particular column. Okay, when we say generate this, then it will only generate that one. It's not adding a column, it's actually generating only a newer column. Here also we are just generating a single column. Okay, we can give it a name. Now, since it's very boring to copy all of the columns back into the output, okay, A, comma B, comma C, it becomes very irritating. That is why they came up with a syntax called dot dot. If you say dot open, all the columns as they were in the input till open will be copied as is. So when we say dot open, it means generate exchange comma symbol comma date comma open. Okay, and if we say open dot close, it means open, high, low, close. All these four columns will be taken into consideration. Okay, and if you want to include all of these, you all say is here you can say dot adg underscore close. Okay, because it's like saying select a comma b comma c comma d and blah blah. It becomes quite boring, right? Yeah, you can pick a few. You can say exchange comma high comma close comma this by doing a comma separating things. Okay, for adding one more column you can say exactly like here. You can here say x. You can say uh, dot 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 adg underscore close comma, and then you can say as my new column. Okay, so basically all you have done is added all the columns as they were in the input and added one more column called close minus open, whose value is going to be close minus open, or you can say a fixed value as 1 or 2 or whatever you want to do there. Okay, similarly the way, and in case you don't know their names and you are sick of typing their name, you can use a back reference like $6 minus $3. $6, 1, 2, 3, 4, 5, 6. Okay, 0, 0, 1, 2, 3, 4, 5, 6, and 0, 1, 2, 3. Okay, so that way you can refer back. Instead of saying close minus open, you can say $6 minus $3, right? So this is how the wildcard correct selection work there. So instead of saying select star, you say this way. Now anybody can anybody answer my question? I'll just write it on the next slide. Um, where were we? We were here. Okay. So since we said that since we said that it is going to generate MapReduce in the background, can somebody suggest me Can somebody suggest me what is going to happen in this case? So, how many reducers will be generated in the background? Since all of your logic, whatever you write in pig, is converted, how many reducers will be there? So, everybody is saying one. Why it is so? Why do we need reducer? for doing the same thing, if you had to do the same thing, take, you are given a file with close and open values, two columns, close and open, and you have to find out a difference between close and open of some value, right? You have got tickers. So say you have got, let me more make this more clear. So you have got symbol name, symbol name, then, and say, then you have got close, and then you have got open. Okay, and say my ticker symbol name is Google, close is 13, and opened at 10. So this is my data, for example. Okay, all I want is that it should generate the output which I'm expecting. It doesn't look very great. Let's say this is the output I'm expecting. Okay, so this is my input, and the output which I'm expecting is, say, close minus symbol name, and the output is diff, and I'm saying all I want is 3, and symbol name is amzn, and my value is 10, say opened at 10, opened at 10, and then closed at 9. Okay, and amzn, or you can just write it this way, no worries. Okay, and 1. This is what I'm expecting. So basically, if you had to write a mapper reducer for doing the same thing, how many mappers did you write? Do you need a reducer for this job or not? Okay, you have, say, 3 values: symbol name, closed at, opened at. Okay, okay. If you have to do mapper reducer, how many reducers will be there? So Shashank, you are saying 0, right? Not, what does it mean? So if you have to do this logic by yourself, right? Uh, so you will write a mapper which will read line by line and do the diff, and your job is done, right? In reducer, you don't have to do any logic at all. Okay. So similarly, in case of pig also, when we write this logic, this logic, it will not generate, it will not generate any kind of any kind of reducers. Okay, great. So anybody has a doubt about this? So I mean, these are very important questions. People will be asking you whenever you are, say, appearing for an interview in data sciences or anywhere. These are the pet questions. So given this kind of generate, for each, generally does not generate any reducer code. Okay, unless there are unless there is a uh, reduction happening, as in for each prices generate average of these values. In those cases, it will generate a reducer. Otherwise, there will be no reducer code, because if you had to do the same thing by yourself, you will also not write a reducer code. Okay, anybody has got a doubt about this? So basically you think of all when I go from one place to another, okay, from top to bottom as we are going, you always think in terms of, what will be the mapper and what will be the reducer. For load, for example, when we said load from this file to that file, it will by default create a mapper. Okay, if you are, because you are going to specify the column names, so this mapper is loading this data by tab separated values. Okay, so whenever you face or look at a pig script, you should, in the back of your head, you should always think in terms of think in terms of total mappers and reducers. Okay, that will give you a very good clarity on what is going on. Okay, so Arun, we were discussing, like, if you are given this kind of a for loop for each condition, how many reducers is it going to generate? Although you can see the answer, but the emphasis is on the fact that every time you look at a pig script or any of the construct, you should think in terms of, is it going to generate any mapper or reducer? Okay, great. Now let's move on. Or do we want to take a break? It's 10:30, 10:20 already. Oh, okay. Yes. Okay, let's take a break of 10 minutes. Okay. Let's come back at 10:34. Hello? Hello? Can you hear me? Great. Great. Yeah. Go on, Hari. What's your question? Mhm. Yes, 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 yes. So your question is that while giving a load command, can we specify a new column which is not present in the file? So whenever we are generating a new value by the way of multiplication or any of the things, uh, then you are basically creating a new column and then you say as this. Okay, you give it a name also, exactly like the way you used to do in case of select. Was he able to answer you? So you say for each these tuples and generate column 1, column 2, and then you say column 1 minus column 2, and as you give it as diff. So diff becomes your new column. This is just an example. Is it clear? Okay. Okay, let me try to go back to the previous screen. So let me just take a copy of it, and let's just take a copy of this and put it here. Okay. We are saying prices equals load this and that into the memory, and yeah, this way, right? Now say I want to say for each prices and say generate. I want to say all the values till here. Okay, exchange to this, or I can actually say this way also, and then I say comma. I'm generating a new value. Say everywhere all I want to do is 12. It's a fixed value. Every column will be a fixed value. I gave it a name as well. Okay, so that's all. Or you can also write it this way. While giving a load command, not okay, okay. For each you can say that, but if you give load command and say you put one more variable here, say xyz, for which the value is not there, then it will mark xyz's value as null. Okay, so you can't do that during the load command itself. Okay, okay, but I have not tried something like saying 12 as uh, no, I don't think so. I don't think so. Okay, right? Load is basically, I mean, a file loader. There is not much of a syntax other than defining data types. Okay. Now let's just get back into more details. If you have to do further detailed projections, such as if your input contains all kinds of other values, say this we talked about, we have prices equals this way, and now we have say we I showed you a baseball type, right? In the baseball type we are trying to dereference the further values. Okay, so we say that load the baseball, okay, this particular file as name followed by this is the batting team, BAT, and then it is a map. Okay, we want to say that that particular column is a map. So now it will load it in this format. And while we are running for each over B ball, then we can dereference the particular value from bat. As we talked that a map has key values, so we want to just pick up one particular value from that each in each row there is a hash map. Okay, in each row there is a hash map. Out of that hash map, we just want to take average, right? So this is how you dereference a map. Okay, you can also say something like 10 into this and all that sort of thing, as well as you could also say things like this plus this, okay, or some other value, okay, some other value, and so on. So this is how you dereference. This is how you dereference dereference a map. Similarly, you can dereference and refer to a tuple like this. Okay, you say while loading, you say that particular column is a tuple of these three values. Tuple is nothing but a row of values, and first value in the tuple is x and second is y, and under that while you are trying to iterate over it, if you just want to refer to the x, then you can say t dot x. While if you want to also refer to the second one, you can either say t dot y. Also, you can say t dot dollar one, because as we talked that tuples is a ordered collection of values where the columns can be referenced using dollar one, dollar two, dollar three. Okay. Similarly, if it's a bag is what? A collection of unordered collection of tuples. And that's how we define it. While we are loading a bag, we say B is a bag in which there is a tuple T, and under the T there is X and Y. Okay. And we say B dot X. When we regenerate it, we can refer to our value X like this. Okay. And similarly, we can also say that uh, give me a tuple which is b dot x comma y. All right, that's it. So this is how we refer to the various kinds of values if they are not they are of complex types. Okay, and further we can do things like this also. So we loaded all of this data and we can give them a name. We can give the values as name like this. Oh, you are late, Bhagwat. Okay. So we can give the columns which we have just created like this, and then we can also check the values like describe in sense. Okay. Now when we talk about here, when we say generate and we executed average, we executed all sorts of functions, you can see a detailed list of functions on this manual. Okay. Here there are all kinds of functions such as average, bag to string, concatenate, count underscore star, then diff is empty, max, min, all sorts of functions are there. Okay, subtract, sum, tokenize. You can use these functions in the generate. Okay, cost and math functions are there. Then floor and ceiling, exactly like whatever these programming languages give you. And things like reverse is the reverse there? I don't think so. No, it's not there. Reverse is not there here. Replace is there, and no. But lowercase, uppercase is there. And there are the date time functions, add duration, current time, and all. So there are a huge list of things, right? A list of functions which you can go through and use in your generate, right? The way I showed you avg function, similarly you can use all of these functions. Okay, so we talked about for each. Okay, now let's talk about something called filter. So for each is clear to you guys, right? So Bhagwat, you haven't missed much, just that I described how you can can refer to complex types like this. Okay. And also I talked about what are the various kinds of functions are there. Okay. Now let's talk about to filter. So similar to where clause we have in SQL, if the where clause is non-indexed, then there is a something called filter. Okay, where you go record by record and only put the records in the output which match a particular condition, like this. Here we are saying whatever records you have loaded, only give out those records where symbol is matching cm dot star. Dot star is typical example of a regular expression. So so these are string matching operators. So here I am saying this. Now this one will contain only the symbols which are uh, it will contain the subset of divs. Divs is a collection of, is a bag of tuples. Each tuple is this. Okay, and basically it's a table. You can think of it as a table. And when you are filtering for the table where symbol is starting with cm, you will have only that particular subset. Okay, so filter is pretty straightforward. Okay, filter is very straightforward. Then let's move on here. Then we have negation. Negation is when symbol does not match some value. And this one. Okay, again a question. I'll just take same thing again here. Okay, here. For this value, when we say this one, how many reducers? Quick. Guys, how many reducers? Anto? Okay, one. How it is one? If you have to do the same thing using your own map reduce, where all you are doing is reading row by row, and then putting only the records in output where cm dot star, where the symbol is matching cm dot star. How many reducers it is going to generate? Are you sure, Bhagwat and Hari? Okay. Hari is sure. Bhagwat, are you sure? Okay. Shashank, let me explain again. So say what you are doing is you are given a task of doing this job. What is this job? Basically, whatever records are there, give out only the records in which the column called symbol starts with CM. Okay, the CM symbol column, the value of symbol column starts with CM. Now, what are you going to do? You are just simply going to write a mapper, okay, which gives out the values as is, e- except for the values which are not matching the CM dot star, right? So there is no, because we are not doing any aggregation at all. We are not doing even a count star, right? Anto is very right. We are not even doing a count star here. So therefore, we do not need any kind of aggregation, and hence there is no need of reducer. Okay. Is it clear, Sashank? If it is not clear, I think you should again go back to the basic mapper reducer once more. And if needed, just ask me. I'll explain to you the whole mapper reducer again. Okay. So is it clear to everybody why there will be only zero mapper reducer? Right, right, right. Great, great. Right. Basically, I'm not able to, formulate a very strong thumb rule where I can, straight away say that for particular operators, there will be no reducer. All I can think of is, and I think about how will I write this, achieve the same objective using my own mapper reducer. If in that case, no reducer is required, that means there is no need of reducer here also. Okay. But as a thumb rule, that's a good point. I'll note it down. Looks like that for filter, almost for all filters, there is no need of any reducer. Thank you, Suksavat. Yeah, great. Now, now order by. Right, right, Bhagavat, right. No, even if we are not processing it, whatever values are coming in, if we are just printing it, that also, uh, you know, m- I mean, no, that doesn't require actually a reducer. Okay. Now there is another construct which is quite, everybody is quite familiar with. It is order by. And order by is standard, like order my set by symbol, and then another column, and then we can specify optionally a descending or ascending. By default, everything is sorted in ascending order. And then there is another syntax called distinct. So given any list of things, any bag, it can give a distinct. Okay. So on a bag, so symbols is a bag, right? Divs is a bag of these values. Or bag, when we are trying to say, is bag means a row, set of rows. Okay. So divs is a set of rows on which we are applied for each, and generated picked up only one column called symbols, and then we said distinct symbols, and then we get only the distinct values out of it. So anybody Let me again put a nice looking, right? So let me again take this, okay, and say distinct. So does distinct uh, require any reducers? Yes, yes, yes. Great, 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 great. Because distinct will have to basically create keys, and then keys will be sorted, and reducer will be just taking it, just printing only the keys, printing only the keys. So that will be the role of a distinct. Perfect. So everybody seems to get it. Awesome. Awesome. So these are pretty straightforward, distinct and order by. Do we have any doubt with respect to distinct and order by? Okay. Okay, that's a nice question. Can anybody answer, Bhagwat? He's saying that I'm not sure if I understand how order by will look like in MapReduce. Awesome. Yeah. Gaurav, okay, Gaurav is not here. Hari and Chintamani and Suksavat and Shashank, Arun, Anto. Can anybody answer him? So order by, when we say order by this and order by that, what does it look like in a map? If you have to do an order by kind of job using MapReducer, what is it that you will do? If you have to achieve the same thing what we are doing here, order by this particular thing, first order by symbol in ascending and then dividend in descending. Right, right, right. So we will have to create a key which is a composite of symbol and dividend in that order. Okay. Or we'll have to form a compare to function, and then mapper will generate that key, and then when the result comes out, that will be sorted by those values. Okay. So most of the job will be done by the mapper itself, and the whole row will be printed as output. Okay. Yeah. So it will definitely require a sorting thing. Yes, yes. So we do a map and okay, yes. So in the reducer, rather than you aggregating the value, you print out the keys and values. Okay. Okay. Or I mean, if you are talking very strict sense in the way our reducers work, where you only give out the aggregation of it, let it be there. Whatever reducer output is there after aggregation, you can basically take that output and key by key you can basically un flatten it out. Flatten it out. You got my point? So we have generated a key. Okay. Okay, we can actually go into that deep, right? So also, I mean, it's sort of, think about it and then we'll discuss it. Okay. Hmm. Fine. Now the important part. How many of you remember the voting example where where we were doing the voting and people were, uh, you know, not everybody has got equal votes. There were different people. So in that, it it was such a tremendous job to join the two tables, votes and the wealth, votes or the value of the votes. It was too difficult to do it. We had to write two set of reducers, right? So same thing is taken care of by pig. They do the joins exactly on the same level. Okay. And if you remember, the way we did the join was the value on which we are joining the two tables, we converted that into the ID in the mapper. Okay. And the rest of the things went into values. The column on which we are doing the joins in both the tables, what we did was in the mapper, we put that as a ID. And when both the things merged, it brought the values together. Okay, so that's how we were merging the two tables. Similarly, here also the syntax is very simple. It says join join uh, table daily or set daily by symbol and divs by symbol. So there are two sets, daily and divs, and we are trying to join these things together, forming a single table based on these values. Wherever these values are same, we are joining them together. Okay. As an example, so let's say we have got symbol A, and we have got value 1, symbol B, value 2. This is our daily value. Okay. And say we have divs. Divs also has a column called symbol, and it has say date. Okay. And it's got 13 July. Okay. And we have got today's date is 26 July, right? So when we join it, it will get converted into something like symbol, value, symbol, symbol, date. Okay. Uh, and A1, and then symbol A again, and then 13 July. B, value is 2, symbol is this 26 July. Okay. So this is how they will get joined. Okay. Basically, it will become tuple like this. and tuple like this. Okay. So Bhagwat's question is, what happens when symbols are not unique, right? Meaning there is a table A in which there are multiple values existing for a symbol, and there are another table on which, so in this case same table will also get joined with itself. Okay. It gets joined with itself. So you can think of those two rows as two different tables, and then you can think of the output, and that will be the output. Okay. Also, while joining, other than joining on a single column, so I mean we have in a same table, so they will become, right, let me just think of it. What will happen? Actually, I haven't given a thought properly. So let's say we have got B and this two. Okay, let's say like this, right? Now what you let's say three. Hmm. So in that case, probably it is going to get repeated like this. It is going to get repeated like this. Okay. Let me think how it is going to do. It is going to create B as the ID, and this is the value, this is the value, and then when this comes here, it is going to, yeah, this is the kind of output you will get. Okay, was it? Did you get it? Yeah, this is the kind of output you are going to get. If you have this, then most likely this is the output. We will give it a try. You also give it a try and prove me wrong after this class, and it will be nice. It will be nice. Because I'm doing a guesswork here. I'm just trying to think if I had to implement the same thing, how I'm going to implement it. Okay. I'm just thinking in terms of map and reduce. How am I going to get converted? Right? Now, we talked about a single value. In the similar fashion, we can do a join on a composite value, a combination of two values. If they are identical, then those rows will be joined. And similarly, you can do the self join provided you load those the same file in two different sets. Okay, if you load it in the same set, the result is going to be very very different. I mean unpredictable. I don't know, I think it gives an error or something. But what you need to do is, in case you are doing a self join, load them into two different sets, and then you do a join. Okay, and then you can do a filter on top of it, and this is how you do a filter. Okay, after joining, when you join the two tables, the column names are generated in this fashion with a double colon. Okay, set name, double colon, and then column name. So the new columns are in this format, and then you can dereference them. Okay, so this is how the pig does the joining work for you. And limits is very, very simple. Okay. Limits is like this. Limit divs 10. That's all. Okay. So you will only get top 10 records. Okay. Exactly. Exactly. Now, there is an important thing which we never thought about, a sample. Okay. What does sample do? Sample basically give you a sample of this data. Okay. It gives you a sample of this data, which is this much of in the ratio. Zero point 0.1 means 10%, 1 by 10th of the total data. Okay. So can somebody guess that uh, this line, will it result in different output at different every time? Will it be random output, random number of random rows from this table, or will it be fixed? Every time you execute, it will be the same sample, right? So basically, it's a random output, completely random output out of this. Okay, so and this is a very nice thing to have. It's a very nice thing to have. So when you are executing your script, so I mean, in my case, what I do is when I'm executing my script, at the top itself, what I do is I do a sample. Okay, in the just after loading the data, I do a sample, which means I'll be just talking to 10 records out of the whole file, and then I will be operating upon only those 10 records. Okay, so when I dump a value, it will be only those 10 records, and hence it will not do a blindness to me. Screen blindness is lot of scroll happened, and I'm just waiting there. And every time I execute my code, I'll have a different set of values to try with. And by the end of it, I'll have lot of different samples I have tried upon. Okay, so same question. So if I run it twice, dump sum twice, will it give the same output or different? So a sample says give me 0.1 fraction of divs. Okay. If I run dump sum twice, will it give the same output or different output? It will be different output. As I told you, the actual execution starts when you are asking for dump. Okay, right. I'll show you. So what we were doing? Say we were loading divs. Okay, and we say sample equals sample divs, and we say 0.01 and say dump sam. Oh, it could not find my file. Okay, because there is a mistake. NYSE. What is the problem? So let me just pig. That's okay. That's okay. And then I say, okay, I have to give an absolute location. Okay. I'll have to give a absolute location. Where is my presentation here? So I say here users slash student slash data, and that's it. And I say dump Sam. Sam is equals to sample divs point 0, and I say dump Sam. Okay. Now look at it carefully, and then again I'm executing just dump. This time the output is different. Okay, output is only this this set. Can you see? Now I'm again doing it. Now this time it is different. This is CSQ, while earlier was not this. Earlier it was something else. Okay. Again, as I told you, when you say dump or store, that's when the actual execution start. No, no. So here till now, it's like declaring functions. We are just declaring these things that this is what, this is a intersection of this, intersection of that. But when you do dump, actually, then the sample is going to get executed. But the variable did not store anything after first execution also. Okay, look at this now. Here you can see that. So basically, I have loaded my New York Stock Exchange dividends into divs. Then I said my sample SAM equals to sample of divs in a ratio of 0.01, which is very small. Okay, which is 1% of the total data. When I say dump and SAM, every time it gives me a different results. Okay, so this is a small sample I have got out of the whole data. Okay, right. So this is the way, this is the way. So see, all the things we said here, this is what you see, this line here, here if you see, this is just a declaration saying divs should have this data. Okay, right now when I press enter, it did not load anything. It did not execute anything. Okay, none of the data got executed right now. Okay, and similarly when I say Sam equals sample this, nothing got executed right now. But when I say dump, then the actual whole the whole plan is getting executed now. So the re-execution happens when you say dump again, the whole re-execution will happen. No. Right. I mean, Anto, I did not emphasize on that part first. In the beginning itself, I said that the first argument, if you give the script file, then it will execute that one. Okay. So you can store all of this and keep on executing it from the command line itself. Okay, so every time you do a dump, it will give a different results. Okay, Bhagwat. Basically, all of these pig commands are not like your SQL. In SQL, when you execute a command, then and there you get an output. Here, it's more or less like declaration. Yes, it if you say dump twice, it is going to load it again. Okay, so this is how it works. So it goes, the thing is, when you are saying store or dump, then it will start figuring out the whole pipeline. It has anyway formed the whole opinion about your data flow, and then it is going to get it executed. No, in memory here. In memory is only that your plan, that hey, you want to do these things. It doesn't store any data. It doesn't cache any data anywhere, at least this side. Okay, it is setting up instruction exactly, right? Now let's talk about limit. Limit is straightforward. We just want to see tail and head as told by somebody. Sample is done. Oh, we okay, done. Okay, right. Now there is an important aspect called parallel. Okay, parallel. So if you remember, the parallelism is the basic premise of pig. Meaning when pigs, it says pigs fly, it means that it will be extremely fast. And that is done using, parallelism is therefore a basic philosophy of pig. Okay, that separates it from other SQL kind of languages. Okay, so if you remember, we were doing partitioning and we were doing all sorts of things. We were also in the previous classes we were also talking about doing having multiple reducers and all sorts of magic, right? Because by default there was a single reducer, and to make it fast we were going to do a multiple reducer. Okay, so to say that I want to do it on multiple reducers parallelly, pig comes up with a construct called parallel and then a number, okay, which you can combine together with almost all the operations. Okay, say for example here, and also this keyword called parallel n, parallel a number, does not have any impact on mappers. Mappers will remain as is. There will be no impact whatsoever of parallel on mappers. The only impact parallel keyword has is on number of reducers you are going to run. Okay. So here when we say group daily by symbol, so it will group the daily by symbol, but the reducers will not be of your choice. Okay. To make it faster, to make it 10 times faster, you put it parallel 10, meaning there will be 10 jobs running parallelly executing this reducer. The reducer which will be generated because of this command. Okay. So the problem with this whole mechanism is that no mapper is going to get impacted. And the optimization which Hadoop is doing, it in case it is giving you
a single reducer, you are making it faster by 10 times. Okay. Also, so and in case you are putting say something like limit, in case of not limit, what was that construct which we told about? Not this, not this, not this. Filter, filter. In case of filter, if you say parallel, it will have no impact at all. Okay. So in case you are putting parallel into anything which is a mapper job, is only has mapper and no reducer at all, then nothing will improve at all. It will be same speed. Okay. Also, parallel needs to be applied per statement. If there are three group by in your script, you will have to put parallel in there. Also, there is a script wide parameter called set default parallel equals 10, but it does not really make sense because every data is different size, and you cannot say that even if your data contains 100 rows, then also you'd have to divide it into 10 pieces. You have to run 10 reducers on it, which will be a sheer stupidity. Therefore, this should be applied and needs to be applied on per statement basis. Okay. And this basically, the other problem with the I mean with the parallel is that it will blindly assume that there is a need of splitting the data. Okay. Even if the data, even if your data is smaller, it will still create multiple reducers. It will still create multiple reducers. Okay. But in general, if you are aware about your data size, put and you are aware about your cluster, giving it a number, generally you give a number of jobs equal to number of nodes, data nodes in your cluster. Okay. And that will so that's the upper limit of giving in parallel total number of nodes, because beyond those number of nodes you cannot run a job. All right. Okay. Again, I'm just questioning you, how many reducers will it produce for each div generate symbol and dividend into 10? Why? Right, right, because there is no aggregation happening, we are just translating from one value to another. Great, great. Okay. Now, in the follow-up question, does parallel clause have any effective in this? For each div generate symbol and parallel 10. Yes or no? Perfect. Perfect. Great. So this is about a keyword called parallel. Basically, it makes it extremely faster to run. Now, somebody was asking me that how do we uh, Pig does not provide you a lot of things, such as we just saw that it was not doing a reverse, okay, string reverse. Or if you have to sort, if you have to sort a character array by characters itself, how are you going to do it? Okay, so in those cases, what you do is either you use Java's built-in functions, a static function basically, for that kind of roles. Or you create your own Java class, put it in a jar, and then add it here. Okay. So this is how you invoke a Java function. First you define hex equals invoke for this string, and we say this. And once this is defined, we can use hex like this. Generate symbol hex that value. And here we are doing casting to int. Okay. So we can use our Java function like this. First we did a translation, and those who are aware with Java, you can do a reflection, and using reflection it finds out the meaning of this one and then tries to execute that one. Okay. Similarly, you wrote your currency converter from dollar to euro using this file, and then you can basically define in the same manner the way you have done, just that you will have to register your jar file wherever you have created your Java. So you will create a new project, say this is my currency converter, and make a static function which takes two argument from one to another, and returns a string or a double or a float, whatever. And then you define in this way, and this is how you are going to use it. Convert this to that. Okay. Similarly, you can also use your Python function in this manner. Register this using Jython as this. Okay. And this function we can call here bball.production. Okay, so this is the syntax, and the more important than the syntax is knowing that you can invoke your Java functions, or you can invoke a library function from Java, or you can invoke Python function from inside of your pig script. That is very important to know. Other than this, there is a legacy way of doing it. It will be in a couple of slides later. Okay, I think I should have kept it this way. Okay. Now there is something called flatten. Those people who have gone through our MongoDB class, they can think of it as unwind. Okay. So you have a particular tuple in this format in which first one is a string and second one is a bag. Okay. And similarly, there is a string and then there is a bag. Okay. So if you want to unfurl it in this format, you know, Sandeep, and make it separate rows instead of same row, then you can use this command called flatten. Okay. So for each x, generate name, comma, flatten your language. Okay. And what is language? Language is a bag. The way we have loaded it is in the form of a bag. Okay, we loaded it this way, where first key is a name and second is a bag of values called languages. And then we have said flatten the languages, which means a single row will become multiple rows, and the repeated values will come into the next columns. Exactly this way. Sandeep, instead of saying C in the same row, we have said C in a one row and C++ in another row. Similarly, similarly, Arun Shell, Arun C, and Chintamani Java, Chintamani C++. Okay, so this is how we do that. Okay, to unfurl it, to make it separate records. Now it becomes easier to do a join, to do other kinds of operations. So that is flatten. Now there is something called for each nested. Okay. What does it mean? For each nested. Say you are given these two sets. One is this, other is this. Now what do you want to do is you want to find total distinct name of people in each city. Okay. Sorry. You are given a single input like this, and here I'm sorry, this is no, this is wrong output. I'll just fix it. So what I'm expecting out of it. So what we want to do is Bangalore. There is one name, two actually, and New York. There are one. So what we are trying to do is find count of distinct names in each city. Okay. So inside Bangalore, we want one. We want to count that. So for doing this, what we will have to do is first group by the city column and then do a distinct over values. And doing this distinct is what is known as for each nested. Okay, this way. Good. So what you do is load people from this people table, and then you group people by city, and then you do this for each group, and now the curly brackets, this is new, right? This is new, and names equal to people dot names, and then distinct name equals to distinct names, and generate a count of distinct names. Okay, and that's it. Okay, so this is called a for each nested, where we are doing operations inside it. And remember, the way we have applied distinct here, we could apply other operators such as order by, okay, order by, limit, all sorts of operators we can apply here. Okay, also you can further apply a for each here. Okay, you can apply for each also here instead of distinct, and so on. So that is why it is called for each nested. So we have the way we have applied distinct on the names which are for the same city. We can also apply other operators which we have discussed earlier, right? So this is how what is called for each nested. We can again apply for each here and so on. If we apply for each distinct here, then we can keep on going further, right? So Bhagwat's question, it looks like when you use, just a second, let me place it somewhere which does not hide the screen. It looks like when you use people inside the loop, it is all the entries within the group. Can we access rows not in the group also within the group? Not really, not really. That's the whole objective of this guy. This is the whole objective of this guy. So all the entries which is grouped together, you can access only those ones. Otherwise, if you have to operate upon other entries, you can operate in other ways. Okay. Just like if you remember when we had this SQL where we used to group by and then say count, you can only do a count on the non values uh, on the values other than the key, and inside only that group by. So this is exactly that way. So group by did its job by aggregating already, and now for each you're going by record by record, record by record. Okay, so you can't do it that way, the way you explain want it. Now there is something called fragmented joins. If you guys are tired, we can discuss it now in the next class. Okay, because this whatever knowledge you had just now is good enough for solving most of the problems. Okay, because we are going unnecessarily, I'll have to uh, do it in hurried manner. Okay, so we can do it in the hive class in the next session, and then we see if we have to push it to push hive to another session or something. Okay, so it is going to take at least 20 more minutes. Okay, so we'll discuss in the next Saturday, and stay tuned. I will be uploading this video and updating the presentation, and also try not to share these videos with all the people who you don't trust, because I'm not editing these videos much. Whatever we discuss here stays there in the video. Okay, so avoid sharing the videos with the random people or on a public forum. Okay, okay, great then. Guys, I mean, I'll be giving a big assignment for today's job. Okay, so this is more or less sufficient presentations in itself. Okay, and I'm making sure that I do not miss out on any of the things. So besides there will not be any other presentations. Also, what I was trying to say is that I'll be giving the assignments by tomorrow evening. Till then, feel free to use Hadoop 3.nobigdata.com to experiment whatever things we have discussed today. Okay, I'll be giving assignments by tomorrow evening, Indian time. Okay, great. Thank you guys, and feel free to get in touch with me. Thank you, Suksavat. Thank you, Hari. Good night. Good night, Bhagwat. Good night, Anto. Good night, Suksavat. Bye bye. Good night. Thank you, Arun. Thank you. Yes, tell me, Sashank. Okay, okay. Good night, Sashank. Then have a great day ahead. And good night, Hari.